Because automated testing like this is a very common problem that has to be solved, there are several solutions out there for writing tests in a more efficient manner and being able to run them very easily. And one such tool is PHPUnit. This has got a huge market share compared to other PHP testing libraries. So this is the one that most people use and the one that's used on most real projects. And that's why I'm going to show you it. It's quite a nice tool. It does take a bit of getting used to, but once you get the hang of it, you will never look back. So before I started using this, I don't know, 10 or so years ago, I would just do manual testing. And then once I discovered this and actually got the hang of it, it really did make a massive difference to the way I wrote code. PHPUnit is a program that's installed in the virtual server that I provide and log into the server using a protocol called SSH or Secure Shell. There are lots of programs that can do that, but the one we're going to be using is called PuTTY. And I'll include a link to this on the Null page so you can just download it, but it is in the notes there. With Linux and Mac OS, they both come with an SSH utility inbuilt, which you can just run on the command line. On Windows, if you want to connect to the virtual server, open up PuTTY after you've downloaded it, and literally the only thing you need to do is put in the host name, which for us is v.je, so it's just the server address that you want to connect to. Everything else can be left as is. There's loads of settings here if you go through it. You don't need to worry about any of them. Just set the host name to v.je and press open. You'll probably get a small pop-up that asks you to press yes or no. Just press yes to it and it will then log you in. If you're on Linux or Mac, open up a terminal and type ssh vagrant at v.je. It will then ask you for a password. If you're using PuTTY, you'll have to enter the username. The username is vagrant. If you're on Linux or Mac, you would have entered the username as part of the connection string when you type ssh vagrant at v.je. So just keep that in mind. And then it will ask you for a password. The password is also vagrant. So the username is vagrant and the password is vagrant. And although it's a bit disconcerting at first, when you type out the password prompt, it doesn't look like anything happens on screen. There's no visual indication that it's accepting the keys. There's no asterisks. It doesn't even flash the cursor. You just type the password and press enter. It will work. You just have to type vagrant and press enter and it will accept the input. But if you're not familiar with it, it does look like nothing's happening. So just be aware that as you enter the password, nothing will appear on the screen. Once you've logged in, you'll be able to type commands in the command prompt. And it's just like a normal command prompt, like when we type vagrant up, but it's actually running commands on the virtual server. So this is a Linux command prompt, not a Windows one. So Windows commands won't work. In addition, it doesn't have access to, for example, your C drive. It just has access to the virtual hard drive that the virtual machine has. There's lots of commands you can type there. The one that we're going to be typing is PHPUnit. That's the name of the program we're going to be using. But before we can do that, we need to run some configuration. And we first need to navigate to the right directory. So cd/srv/http. That will navigate you to the folder that is equivalent to the websites folder in your file browser. So when you go into the websites folder, that's mapped to the virtual machine on this path. So /srv/http. That's where it maps to the websites folder. And anything in the websites folder will be available in this folder on the virtual machine. If you type the ls command, that's short for list, and it will show you the contents of the directory. And if you type ls, you'll see a list of everything that's currently in the websites directory. So you'll probably see your database.sql, you'll see the default folder. If you've created different folders for different assignments or different weeks, you'll see those as well. And hopefully you'll see the jokes website. So if you want to go into the jokes website, you can type cd jokes, and that will then take you into the jokes folder. And that's what you need to do before running PHPUnit. You need to ensure that you're in the correct folder. So /srv/http/jokes would be the full path, although you can go into srv/http and then go into the jokes folder from there. That's step one, is making sure that you are in the right folder. Once you've navigated to the correct directory, you can try running the PHPUnit command. This will run the command that will test your code. Obviously, there's nothing set up yet, and you need to provide a small amount of configuration to make it work as intended. If you run the command and see output like this, you can see that it's doing something. That's just the help page for the command. We don't need to read through it. All we need to do is know that when we run the command, it has to be run from the correct directory. So that would be your jokes directory or your AS2 directory or wherever. And you need to provide it a bit of configuration. You can do this as part of the PHPUnit command, but rather than doing that every single time you want to run your tests, it's better off putting a file called phpunit.xml, which describes the configuration. Put this in the specific site directory, for example, website/jokes, and then create a file called phpunit.xml. And all of the test code is going to be in the directory called tests. So we'll have a new folder called tests in the jokes directory, which will contain all of our test code, and a file called phpunit.xml, which is the configuration file for PHPUnit. And you can generally just copy and paste this configuration file. There's not much here. All you really need is this line. You can just copy and paste this as is without worrying too much what it's doing. All it's really doing is saying that the directory that contains the test is called tests. So if you want to create a folder with something else with a different name, you can do that here. But I recommend just using the test directory, and then it will scan any PHP file in that directory and count them as a test. We're not quite ready to run our first test, but if you run the PHPUnit command after you've created the config file, you should see some slightly different output. So you'll see some output that looks more like this: no tests executed or something to that effect, rather than just the help information from the PHPUnit command. And if you see that and it's changed, you know you've got the PHPUnit.xml in the right directory and you've navigated to the correct folder as well. The next thing to do is create a folder called tests in the websites folder. So it'll be website/joke/tests. It is case sensitive, so if you referenced it as tests lowercase in the XML file, then please make sure that you use a lowercase directory when you create it. And to create a test, you need to create a file that ends in the word test with a PHP extension. So it'll be something test.php. And it does have to have an uppercase T or it won't work. Again, it is case sensitive. So it'll be something test.php. So for our registration page, we could create a file called registerusertest.php in the test directory. And the way that the test works is you create a class as normal with the same name as the name of the file. And that has to be the case because it uses its own autoloader. So create a file with the same name as your class in the test directory. And it also has to include this: extend /phpunit/framework/test case. I won't go into what that extends is doing today. It doesn't really matter. You just need to put that on there so that it can be treated as a test. And when you run the PHPUnit command, it scans the test directory for any file that ends test.php, then loads the file, loads the class inside it, and then treats each function inside the class as its own test. But it's worth running the PHPUnit command again at this point because you'll get a slightly different output. It should now say no tests found in class and then the class. But what this does tell you is that it has correctly found and loaded this class. So it has correctly loaded the class, even though there's nothing inside it to actually test at the moment. We're now going to create a test, and a test is a function in the class that starts with the word test. Now, I don't know why they designed it like this. The way they designed PHPUnit is a function that acts as a test has to start with the word test, but the class has to end with the word test. Seems inconsistent to me, and I would have done it consistently if I was designing it, but unfortunately we're stuck with it because that's how it works. But each test starts with the word test and then has a specific name, and this name is something you give it. So it has to start with the word test. The rest is chosen by you. And it's good to give it a descriptive name, because if the test fails, it tells you the name of the function that failed. So if you call this just test1, it will say test1 failed. Whereas if you call it test invalid email, it will say test invalid email failed. And you'll then know roughly what was wrong. So it's good to give it a descriptive name. And you don't ever need to write the function name again. So it doesn't really matter if you make it really long and unwieldy, because you never need to write out the function name. It's called automatically by PHPUnit. So after adding the function, even though there's no code in it, we can run the PHPUnit command again, and it will say something like this. This test did not perform any assertions. That's because the test isn't actually doing anything at the moment. But we can see that it is running this test, and it knows that it exists. It's just not doing anything because there's no code in there. So what does it mean by this test did not perform any assertions? Well, an assertion is something you'll need as part of your tests. So each test should have one or more assertions. And an assertion is basically a fancy if statement that says, if this function returns this value, mark the test as failed. So you can add assertions through your test, what you're expecting to happen. So you're asserting that something should be happening. So for example, a function should be returning false at this point. And if it doesn't, then the test has failed because the code isn't working as you're intending it to. So for example, a very simple assertion, and there's lots of these, a simple one is assert true, which takes a variable as an argument. And what you're saying when you include this line in the test is, at this moment in time, I am expecting that this variable is true. And if it's not, and in this case, I forced it to be false above, but normally this would be the output of a function or the return value of a function. I'm saying I'm expecting it to be true. If it's not, and you run the PHPUnit command, it tells you that this function or this test failed asserting that false is true, and tells you where the issue is. So it tells you that the test failed, and then that gives you an indication that you need to go and look at the test and then look at the code that it's running to check what's going on. Let's have a look at more of a real life test. So if we had a function called saveuser and we had that in saveuser.php, we'd need to load that file using a require statement. We don't want to put it in the same class as the test because we want to actually use the function on the real website as well as in the tests. And that's the important thing here. We should be testing the functions that we're using on the real website. So we'll just use require statements to load any classes and functions that we want to test. And there's lots of types of assertions in PHPUnit. I won't go over all of them, but a useful one is assert equals, and that just checks that these two values are the same. If these two values are not the same, then it marks the test as failed and will tell you that something's wrong with the code. So let's have a look at the validation function from before. Here is the class. So you can see there's quite a lot of code here, and we'll go into how we can minimize this a bit later on. But we've got the test called test invalid email, and I'm creating an instance of the author class so that I can test the validate registration function that I introduced at the beginning of this topic. So that's the function that we're testing. And we're saying that with this test data, with a missing email address, there should be one error when the test runs. If there's not one error, if there's 0 errors or more than 1 errors, then the test will fail. And the assert equals will say, okay, check this is the same as this. And if they're different, then the test fails. Otherwise, the test passes. Unfortunately, because this function is in this class, we need to create an instance of the author class. But because the author class has a constructor that says it needs a database table instance, we need to create a database table instance. And because the database table instance needs a database connection, we also need to create the database connection. I'll show you how we can avoid this later on, but for now, we'll just connect to the database and create all of the objects that are required. Unfortunately, in a real system, you might have one object that requires an instance of something else, that requires something else, that requires something else, that requires something else, that requires something else, and you end up with 10 or 20 depth of objects. And that's not ideal, and I will show you how to avoid it. But for this quick example, I've created the instance of the author controller as I normally would, created my test data, ran the function that I'm testing, which is this one here, with the test data, and then said, if this test is working correctly, if this function here is working correctly, given this test data with the missing email address, I would expect that there is one error message. So I'm counting the number of errors. I'm saying there should be one. So I'm checking to see if these two things are the same. Is the number of errors equal to 1? If it is, then I know the function's working correctly. If it's not, then I know there's something wrong, and I'd have to go and edit this function. So what I would do is I'd run this in PHPUnit. If PHPUnit tells me that the test failed, I would go into the function, change the function, work out what was wrong, and then rerun the test and keep going through that process until the test passes. And when the test passes, PHPUnit will provide an output that looks something like this. So it will say, okay, one test, one assertion, and that means that the test's passed. And if the test passed, it means that this function is working as intended, or at least it is when given this particular test data. So now we can add more tests to the class so that it can check different situations. So for example, a test with the invalid email and a test with valid data. And we're saying when the data is valid and we've got values for all 4 form fields, this function should return 0 errors. And if it does, and this test also passes, and this test passes, and we added some more tests as well with different things, then we would know that the validate registration function is working as intended. And any time that we make a change to the function, we can just rerun all the tests, and we probably have 4 or 5 different tests, as I outlined at the beginning, 4 or 5 different tests. And then every time we make a change to the function, we'll just go in and rerun the tests and then check that we haven't broken something that was previously working. One thing you would have noticed is that for each of these functions that we're testing, we're going to have to go through and connect to the database, create a database table instance, and then create an author instance. So we're actually going to need to create this entire object. And that's quite a lot of repeated code that we're going to need to do in each part of the test. And every test for this class is going to need to create an instance of it. So what we can do instead is use something that's inbuilt in PHPUnit called the setup function and call it before each test. So this function gets automatically called before each test, and anytime you'd have code that would normally go at the top of each test, you can just put it in this function and it will get run automatically. And like any class, you can create a class variable that's available in every function in the class. So this setup function is going to be run automatically. And when this setup function is run, it will connect to the database and create this author instance and write it into the controller variable. So we're actually writing it into the class variable called controller. And now for each test, rather than repeating all of this code, we can just use this controller validate registration and reference the class variable. And that means that we don't need to include all of this code at the top of every test. Each test now can just use this controller and read the class variable which has been created at this point.